In this video note, we're going to look at some of the choices available for iteration over a collection in Java. We're going to use the Music Organizer project to do this. We're starting with the initial version that simply contains a list of file names of strings. What we have already are 4 different versions of a basic iteration that allow us to list out the names of the files. One version with a for each loop, one with a while loop, one with a for loop, and finally another version of a while loop that uses an iterator rather than an integer index. Firstly, we'll just review the basic characteristics of each of these options. With a for each loop, it's very easy to do basic iteration because all of the management of moving through the list is taken care of by the loop itself. The header contains the declaration of a variable that is set in turn to each item in the collection, and in the body of the loop we simply use that variable when we want to access each item. The for each loop works particularly well with collections that don't necessarily have integer index values associated with their contents. The linked list class is one particular example of this, where linked list and array list are very similar in terms of the functionality they offer, but the linked list does not store its objects in an integer index data structure. In this version of the method, we're using a while loop. Here we have to arrange for ourselves all the access to the items in the list. For instance, declaring an integer variable to index into the list, testing whether the variable's value is still within range of the items within the collection, and then using the variable to retrieve each item from the collection in turn. We then have to remember to update the index each time around the loop. In the third version, we're using a for loop to access the items in the collection. A for loop is in fact very similar in character to a while loop. We still have to declare an integer variable, we still have to test the variable's value to make sure it's still within range, and we still have to update the variable explicitly each time around the loop. Only the syntactic structure of the for loop really makes it differ from a while loop. The fourth version illustrates the use of a while loop with an iterator. We ask the collection for an iterator object, and thereafter we use the iterator object to manage the loop. Notice that there's no integer index involved, so just as with the for each loop, the iterator solution works well where the collection does not necessarily store its items where they can be readily accessed via integer indices. Now let's look at the task of searching the collection to see if a particular file name is in the collection. Once again, we've prepared a version of the project to illustrate these ideas. The first version uses a for each loop. Inside the body of this for each loop, we've got a test to see whether the current file name matches the one that we want. However, now we have a problem. What do we do if we find the file name we're looking for? The problem is that a for each loop is really designed for the situation where we definitely want to iterate over the whole collection. If now we change our minds and we want to stop iterating partway through, we have to find a means of escaping from the body of the loop. That means we're really giving a mixed message to the reader of our code about what the loop is intended to do. Using for each loop suggests we're going to go all the way through the collection, but then in the body of the loop we decide we want to stop partway through. So rather than completing the body of this method, we prefer to say that a for each loop is not really appropriate if we want to stop partway through. We prefer to use a different solution instead. In contrast, the while loop is much more suited to this task. The fact that it has a Boolean expression to indicate the conditions for continuing the loop means that we can stop the loop by making this condition evaluate to false. In this case, we want to stop if either we've searched the whole list and not found what it is we're looking for, or we've managed to find what it is we're looking for, in which case we use a Boolean variable found, and we can set that value to true inside the body of the loop. Notice too that we make a choice over whether we're going to update the index variable or not in the case where we find the item. We've chosen not to update it here, which means that the index variable will contain the value of the item we were searching for when the loop finishes. In some situations this will be useful. For instance, if we wanted to return the position from this method instead of simply true or false, then the index variable contains the information that we want. The third example is the for loop. As we saw before, a for loop is really very similar in nature to the corresponding while loop. However, a significant difference in this case is that we haven't actually prevented the index variable from being updated in the case where we find the item. So in this case, the index variable will not contain the position at which it was found once the loop finishes. Since the while loop and for loop are so similar in character, it can make sense to apply the same convention as we did with a for each loop. That is, we'll generally choose to use a for loop when we intend to iterate over the whole collection, and use a while loop otherwise. The final version uses an iterator and differs little from the previous while loop version that we saw. However, here there is no integer index variable to manage. So once again, the issue is really a question of whether the collection is best accessed with an integer index or not. Remember, one of the primary reasons why we lay out code consistently, comment clearly, and adopt naming conventions is to make our code easily comprehensible. Because there are so many alternative control structures for iteration, our choice in a particular situation could make our code easier to understand. For instance, a for each loop is the natural choice of loop when we definitely want to iterate over every item in a collection. If therefore we choose it for a search situation where we might want to finish the iteration prematurely, that gives a mixed message about what we're doing. So we prefer not to return from the body of a for each loop, or break out from it partway through the collection. In contrast to the for each loop, a while loop allows us to express in its condition exactly the circumstances under which we wish the loop to continue. When we wish to stop, then the Boolean negation of the condition will express this. Furthermore, if there's any code following the while loop, knowing exactly how we got there, because the loop condition is now false, can help to simplify the logic of what follows. So this example of search using a while loop should be seen as providing a basic pattern for search-related tasks on collections involving integer index values. As well as being particularly useful with collections that don't necessarily use integer index values, iterators come into their own when items must be removed from a collection. Using an iterator saves us from the danger of not keeping an index variable correct if items shift in the collection after removal. In summary, we have at least 4 choices for the way we approach basic iteration over a collection of objects: for each, for, while with an integer index variable, and while with an iterator. The choice can often be simplified by deciding whether we definitely need to iterate over the whole collection or might stop part way through. In general, we try to avoid breaking out of the body of a for each loop or for loop. An iterator is particularly useful where the collection is not naturally accessed via integer index values or where items are to be removed from it.